So in the previous video we discussed the first two steps of secondary growth in a dicot root. Now before continuing with the third step, first we will draw diagrams related to these two steps. So the very first diagram I am going to show the structure of a typical dicot root. So you can use any bangle or compass to draw circular outline, and we need to increase the radius with every step. Okay. And in the center we need slightly smaller circle which will represent the steel area. So you can mark it as a dotted line. So what is the primary structure of the root? If we cut its cross section, transverse section, you have to divide this area into an X like structure. They should be almost of equal size. Okay. Now the central portion, in order to differentiate it, I am drawing lines in this area. This marks primary xylem. Now alternating to this primary xylem, we have primary phloem. This is the area of primary phloem. So if we are talking about a tetrarch root, 4 patches of phloem alternate with xylem. That's why it is called tetrarch, and they alternates. So we say the arrangement is radial. Okay. Now outside this, there is a layer of pericycle. Because we are drawing line diagrams, these are not cellular diagrams, so each line represents a layer. So just close to the central circle, you will draw another line in order to show pericycle. So this is epidermis, then we have cortex. The outer line represents pericycle, inner line represents, this outer line represents endodermis, then the inner one represents pericycle. The pink patches are primary phloem, and the central one is primary xylem. So pith is absent in this case. This is TS of a dicot root, and it is the primary structure. So now we will be starting the steps of secondary growth. So in this root, the very first step was development of vascular cambium. So for vascular cambium, in order to show that, you have to use same radius. Again, draw a circle. And of the same size, the smaller one. So we will divide regions again. So the areas of xylem, the alternate patches of phloem endodermis. So this is the primary structure. Now in this we will show the formation of patches of vascular cambium. Now in order to show those patches, I am using red color. So this region which is in between phloem and xylem, that will serve as the cells which dedifferentiate to give rise to as many strips of cambia as are phloem patches. If you have a wider area, you can divide it into two tails. Okay. So this area, which was the region of conjunctive parenchyma in between phloem and xylem, that becomes meristematic. It dedifferentiates and give rise to the strip of vascular cambia. Now these are discontinuous. Okay. In order to make it continuous, the region of pericycle just opposite to protoxylem, it also becomes meristematic. So in this area, you will draw the remaining strips of vascular cambium. Okay. With the vertical lines, I have denoted the area which represents vascular cambium. So rest of the things are same. So the vascular cambium, one, it develops from the region of conjunctive parenchyma, and the other is the region of pericycle present just opposite to protoxylem. So whenever we talk about the primary structure, towards the center xylem elements, they are larger. They are the elements which are having broad vessels and tracheids, that is called metaxylem, whereas the elements towards these corners, towards the outer side, these are slightly smaller in size and they are earlier formed elements which are called protoxylem. So, the pericycle which is present just opposite to protoxylem, that is going to contribute to vascular cambium. Okay. So, in this we have, this is a step number 1 now, the formation of vascular cambium. Now, the next step will be the activity of vascular cambium. So, that step will be in continuation. Now, we will increase the diameter. Okay. So, with the previous dimensions, now take slightly bigger circle. And the central region, that also slightly larger. In the center, we will demarcate the phloem region. Okay. They should be slightly broader, and now draw the vascular cambium somewhat straight. So, this ring in this region and then the cells from pericycle, again continuing with the strip of conjunctive parenchyma, 2 cells of pericycle, again the strip of conjunctive parenchyma, so it should be a continuous ring, but earlier it was with the curves. Now, you can draw a diamond shaped structure. Now, we will erase this outer region in order to show primary phloem and secondary phloem. Okay. So, mark this area like as we did earlier, primary xylem, and this fresh patch that developed from vascular cambium strips is secondary xylem. And towards outer side, you will show the patches of primary phloem it starts getting crushed. Just a little amount of primary phloem. And the in between area with secondary phloem. So, I am marking secondary phloem with this fluorescent color just outside the red and pink. In between that region you have to show secondary phloem. Okay. So, in the first step vascular cambium strips is formed. In the second step the vascular tissues develop. So, this is activity of cambium, where we discuss the formation of secondary xylem and secondary phloem. So, the labeling part, this is crushed primary phloem. The fluorescent part, secondary phloem. Red colored strip, vascular cambium. The dotted part, secondary xylem, and the central portion, primary xylem. This is how secondary vascular tissues are formed. Now, we will continue with the activity of cambium, that is how the medullary rays are formed. So, that will be the last line diagram, because ultimately we are going to draw a cellular diagram. So, again bigger than this size. There should be always a slight increase in size. Okay, don't show very large drastic variation in the sizes. A gradual change should be shown, and in the central region also slightly larger. Okay. So, in this diagram we are going to show the formation of medullary rays. So, we will mark center, but now the central star shaped area, it should be away from this line. Okay. So, mark the area, star shaped area at 4 different points for primary xylem. So, this is primary xylem, and outside this now we will draw with a little gap the vascular cambium. Okay. It should be in between the area left. So, you can make it look distinct by making a row of horizontal cells. So, this is vascular cambium. Okay, now in order to show some gap, again you erase this line. This was the central part. So, now we can draw a line slightly away from this line. Okay. We need this area to mark secondary phloem. So, the patches of primary phloem, crushed patches just opposite to the curved areas. Then this is the region of secondary xylem. And outside is secondary phloem. But before this, mark the regions of medullary rays. So, the cells of vascular cambium which got differentiated from pericycle, they do not cut secondary vascular tissues, rather they cut secondary medullary rays, primary as well as secondary. We will discuss this later on. So, in this area no dotting should be there. The area which is under the diverged lines, these are the areas of medullary rays. So, this vascular cambium towards inner side and outer side is going to form medullary rays. We can mark this area with a separate color. These medullary rays which are arising directly, they look appearing from the protoxylem. These are called primary medullary rays. Okay. So, both towards the inner and outer side, and now the area left, this is of secondary phloem. And in both these diagrams you will show endodermis. See, when the area of the central cylinder is expanding, definitely there is some pressure being forced on the outer parenchymatous cells. Okay. So, in this region, so now we have primary phloem, I will use abbreviations, secondary phloem, medullary or vascular ray, secondary xylem, primary xylem, and vascular cambium. So, this is again under the activity of cambium, the formation of medullary rays. Okay, so we will again revise the steps. This is the general structure, the primary structure of a dicot root, in which we have, if it is a tetrarch root, then we have the central part filled with primary xylem and alternate 4 patches of phloem are present. In between xylem and phloem, the area is called conjunctive parenchyma. Now, as the secondary growth starts, the very first step is the formation of vascular cambium. So, the region of the conjunctive parenchyma cells, they become meristematic and they result in the formation of 4 strips of vascular cambium. Similarly, the cells of pericycle, which are present opposite to protoxylem, they also become meristematic in order to link these 4 cambial strips so that a complete ring of vascular cambium is formed, but it is wavy at this point. Then this vascular cambium is going to cut secondary vascular tissue, that is secondary xylem towards the inner side and secondary phloem towards the outer side. The amount of secondary xylem added is more as compared to secondary phloem, that is why slowly and gradually this vascular cambium ring will circularize. In the next cambial activity, the region of the the cells of cambial initials which are present in the pericycle part, which are opposite to protoxylem, they will divide and give rise to parenchymatous cells towards inner and outer side. These radially elongated cells, they are called medullary rays. Their function is the conduction of substances in the radial direction.